Coming to publications, he has published two articles on blockchain technologies and received Best Paper Award, which is present in NIT Jaipur. He has delivered many sessions on blockchain technology as a resource person. Currently, he is working in IT industries, Avenir Systems. Pleasure having you, sir. Over to you, sir.
Resource person. Currently, he is working in IT industries, Avenir Systems. Pleasure having you, sir. Over to you, resource person.
Thank you,
Currently,
ma'am.
he is working in IT industries,
Thank you, sir.
Avenir Systems. Pleasure having you, sir. Over to you, resource person.
Thank you,
Currently,
ma'am.
he is working in IT industries, Avenir Systems. Pleasure having you, sir. Over to you, resource.
Uh, Good afternoon, everyone. So today I'll be discussing blockchain solution for healthcare systems. Before going to directly to the healthcare systems, we'll give a little bit introduction. It will not be a detailed one because since 1.5 days we have already seen some introductions about blockchains, which has already happened in previous sessions. I'll just go through some of the overall architecture of a blockchain. So initially, it was introduced in 2008 with a group of people. Name is not known. So as a Bitcoin was the first application. So later they introduced it as a blockchain technology. Okay, so the main reason why blockchain technology is created is instead of always trusting on third party, it's better to have open. So it's like a public ledger, distributed public ledger we can call, so that everything will be open and everyone can see all the transactions happening. Because whenever if you are in giving some our resources to some trusted third party, so it may happen like they can change our data, they can uh, share our data without owner's knowledge. Okay, so that is the main agenda why blockchain is introduced. And one of the drawback of the current system is a centralized system, where a single point of failure can be more. So always they need to have a backup as a uh, replication, and they always need to have a backup. So distributed ledger concept, the main core concept of the blockchain, where all the participating nodes, if you can observe here, person is there awaiting, okay, some banking system, group of people are there. So these are all participating nodes to a particular blockchain network. Okay, so each person in the network will have a copy of a ledger. Okay, so it will be the ledger, same ledger, everyone will be having all the participating nodes inside a network. Okay, so this one will clearly shows the difference between centralized and decentralized and distributed. In centralized system, what happens?
Mr. Raghavendra ji,
Clearly shows, yes, sir, the difference between centralized and decentralized and distributed. In
yeah, whether
centralized
YouTube
system,
is
what
on in
happens?
your system?
Mr. Raghavendra ji, clearly shows, yes, sir.
Can you close it, please?
No, sir, YouTube is not.
Whether YouTube is on in your system?
Mr. Raghavendra ji, clearly shows, yes, sir.
Can you close it, please?
No, sir, YouTube is not.
Whether YouTube is on in your system?
Mr. Raghavendra ji, clearly shows, yes, sir.
Can you close it, please?
No, sir, YouTube is not.
Whether YouTube is on in your
No, sir, not with respect to this, sir. Because I am hearing this voice again and again, sir. No, sir, not with respect to this, sir. Because I am hearing this voice again.
1 minute, 1 minute.
Because I am hearing this voice again.
1 minute, 1 minute. One minute, 1 minute.
Hello, sir.
Raghavendra, there is a complete echo. Raghavendra, there is a complete echo. ಗೊತ್ತಾಯ್ತು. ಏನು ಒಂದು ನಿಮಿಷ ಒಂದು ನಿಮಿಷ ನಾನು ಕಾಲ್ ಬ್ಯಾಕ್ ಮಾಡ್ತೀನಿ ತಾನೆ. ಹಾಂ, ಹೇಳಿ ಹೇಳಿ, ಬೇಗ ಹೇಳಿ, ಬೇಗ ಹೇಳಿ. ಗೊತ್ತಾಯ್ತು. ಹಲೋ ರಾಘವೇಂದ್ರ ಜಿ,
I can hear you, sir. Sir, can you hear me?
can you share your screen please?
Yes, sir. I have this one more. I can. Sir, can you see my screen? Uh, that's what, sir. Change one more mic is there, sir. I can change it. Yes, sir. Hello, sir. I just joined a new system. Yes. Hello, sir. Hello, sir.
Hello, sir.
Can you hear me?
Yes, I can. We can hear you. Your voice
Yes.
is loud and clear. Please
Okay,
share
sir.
your screen.
Hello, sir. Hello, sir. Can you hear me?
Yeah, yes, I can. We can hear you. Your voice is loud and clear. Please
Okay,
share
sir.
your screen.
Hello, sir. Hello, sir. Can you hear me?
Yeah, we are.
Sir, actually, some delay in the streaming, sir. Hello, sir.
We can hear you. Please share your screen and continue with the presentation.
Okay, sir.
Okay.
Okay. Hello, everyone. Sorry for the interruption. Okay. Uh, so, am I audible now? So this is it shows basically difference between centralized, decentralized, and distributed. So centralized, there will be always a single point where a decision will be taken at one point. In decentralized, decisions will be taken individually, but again the final decision will be made as in the master node. Okay, so it's like a master slave node. Distributed, actually decentralization is a subset of distributed. So distributed, along with the decentralization, some other tasks will be taken. So for example, if we take example of a Google replay page, so whenever I type google.com, it will be coming from different systems. We will think that there will be one system. So that's how distributed work. So this is just a basic introduction to blockchain. As we have seen, it's a public distributed ledger where all the participating nodes will be having same copy of a ledger. So these are the core components. If you see, I have arranged this in a process how this blockchain will occur. So initially transactions where we'll be having source address and destination address along with the data. So if we take we can take example of financial transactions. So data will be some Bitcoin or money. Okay, so if we take it depends on implementation where we want to use when if you want to use it for insurance company, we can take example of insurance report or insurance copy. If you take healthcare systems, we can take an example of health reports. Okay, so smart contract is basically through which it's a piece of code inside a blockchain, so that so this smart contract will not be in someone's hand. And when a person takes over this smart contracts, it's like he's controlling the system. So it should not be in someone's hand, it should be within a blockchain, or it should be within a block, Suppose whenever person wants to create a new smart contract, so for that new block will be created. Okay, so for miner, once the transaction is created, it will come to a miner. So miner has to verify. So miners are like they are specifically for verify the transaction. So whenever we go to bank, so banking, so all the bank employees are specifically for verifying our transactions. So and all the rest of our customers are like participants to a blockchain. Okay, so a miner can be participant as well as miner. Okay, once the miner is verifying all the transactions, it will be added to a block. So that block will be broadcasted to the all the miners within the network. Okay, so here two things will comes into picture. One is public and another one is private. So public, we can take an example of a proof of work, and another one is so there are many consensus algorithms are existing. We can take example of proof of stake, delegated proof of stake, proof of elapsed time, proof of waiting time. So there are many consensus algorithms are existing, but mostly we'll be getting to know only two main consensus algorithm. One is proof of work, another one is proof of stake. So in Bitcoin, proof of work is using, which takes a lot of computational power. So next we come to a consensus mechanism. Once that block is accepted, it will be broadcasted to all the miners, so that all the miners can add that block to their chain. Okay, so this is complete flow of a blockchain. So why blockchain is the best solution for healthcare system? So I can tell, anyways, from 2007 to 2017, there are around 176 million patient records have breached. Okay, so this is very huge data. Okay, so why blockchain? There are solutions existing previously, but blockchain has something which it shows some of the more properties where it can give more security towards the healthcare systems, that I have listed out some of them, where securing patient data and easy and safe interoperability. Interoperability plays very important role in healthcare systems. So what does it mean? Whenever some patient goes to one hospital, so he has some record, he has some reports, so that report has to be shown to some other hospital. Okay, so that is where interoperability comes. So that report can be shared to insurance people, where he can claim by showing all the reports. When it can be shared to research people. Okay, so this is where interoperability comes. So during this time there may be some breaches, some maybe data compromise may happen. Okay, it's not compulsory always it should happen, but there are some people who can sell these data for money purpose. Okay, so immutable behavior in blockchain. Once that data is created inside a blockchain, it cannot be changed. Okay, so this will very much helpful in uh, for claiming or something. Okay, no hashing technique required. In previous, there are some techniques existing where records will be passed through hashing, and that hash will be stored. Okay, and data can control at various level. So here in transaction also you can have data what you need to store inside a blockchain. Again, next level comes to a smart contract where you can control over the data. Okay, so whether you want to share this data, so this data can be controlled, like I will show you the picture of that, how data control can be done through blockchain. Okay, so where blockchain can be placed in healthcare system. Okay, so this is one diagram we have designed for our proposal methodology. So this is already published paper. I have taken a diagram from that paper. If you see here, user layer, uh, so user layer, all the participants. Okay, it may be patient, it may be insurance guy, it may be a researcher, anyone, doctor, so anyone, they're all users. So they have to first register, that is query layer. So for that there will be one registration will happen, and along with that all the details will be stored, basic details. Okay, so it will be with the healthcare system. It will be like health organization, that particular organization, it's a private organization what we have designed. This is not a public organization. So this all the details will be with healthcare organization or hospital. So next layer, whenever that report comes, that report will be passed through IPFS generator. So why we are using IPFS hash generator? Because blockchain's drawback is we cannot store complete data over the blockchain. So for that, we are storing this record on a IPFS so that we can take that hash value, we can store it in blockchain. So this is one main property of IPFS. So IPFS, I will tell more detail in a coming session. Okay. So once that hash is generated, we are like storing our data is safe. Our data is cannot be changed. So even a small pixel of data is changed, a huge difference in the hash value. Okay. So it is then it will be passed through smart contract. So in smart contract, I'll show a couple of smart contracts what we have created in our research work. So this smart contract will control the data, whether I have to share it to some other person, whether I don't want to share. If I don't want to share, then it's like patient's interest. Okay, if a patient want to share, he can give access to that person. Otherwise, no need. Okay. So but without patient knowledge, the data should not be shared. That's like a patient's privacy is required. So it's like a data structure and controlling layer. So indexing we are creating because IPFS, what it will do is it will store data locally. Okay, so whenever I upload my data, it will store locally, but I will not keep track, I cannot keep track of that hash value. So for that reason, I am making some indexing file where I am storing that hash value, through which I can directly download the data. So this I will show you demo in coming session, how I can directly download that data, because IPFS is interplanetary file system. So where a record is created, that hash is created for a record based on its content. Even though a small pixel value, it will change in the large hash value. Okay. So next, once that transactions is created, when indexing is created, that transactions will go to blockchain. So all only in blockchain, I'm storing only transactions, not anything else. Okay. I will show what are the things I'm storing inside a blockchain. Then when it comes to IPFS, I'm storing the record. Okay. It's not like record something data center is existing. It's stored locally. I'm enabling my system as a IPFS system. So my system, one system can be acted as server as well as a client. Okay. So I can download my system. I can download the documents from within a system. Okay. I hope this one is very much clear. So if you have any doubts in between, you can ask me. This is one proposed methodology we have given. How blockchain is implemented in healthcare system. So I have told you we can control the data over transactions as well as in smart contract. So for transactions, when it comes to healthcare system, it's not a financial data. It's like health reports. It can be health reports or lab test reports or a doctor's note. Okay. So some such things it will be included in a transaction. Smart contract, when it comes to smart contract, we can access control on patient data, and we can give permissions whoever wants to see the data, and we can revoke that data as well back. Okay. So minor, when it comes to public, anyone can participate. So I hope when it comes to an particular organizations, it's preferred to use private minor, so that some predefined minors are there. So again, minor selection is again a big topic. Okay. So here one thing I want to make clear that we are using it for a application purpose. So we can consider some of the built, we can make use of some of the existing tools. Okay. So in that, some default settings will be there. As I have mentioned, for example, Ethereum, Quorum, and Hyperledger. So Ethereum, this will give some of the predefined settings. Okay. So in that, I have not changed anything. I just make use of those things. Where I have changed is transactions I have changed and smart contracts. Okay. So these things plays a very important role, because for transactions, what data I need to store inside a blockchain. For smart contracts, whether what are the permissions I can give on smart contract. So this is some of the smart contracts we have written in our methodology. If you can see this, we are giving permission to what patient can give permission for others. Okay, so message dot sender will always show who is making a transaction. So always patient will make a transactions. So this again implementation wise, suppose if he wants to take some money, it can be charged. Otherwise it's his dependency implementation purpose. Okay. So here, excuse. So here we are giving permission to doctor. He will enter something. So once he entering is done, we can revoke his permission. So that will be stored inside a blockchain. This one we are giving access on record. So here we can some of the data we are storing inside a blockchain. It's constructor we are using, record ID, patient ID, and doctor, and key we are storing. Along with that, IPFS hash we are storing. Okay. So I hope this one is very much clear. This is a basic smart contracts which is written on Solidity language. Solidity language is a language specifically preferred for creating a smart contract inside Ethereum. Okay. So a smart contract can be written in any other language. If you go for Hyperledger, there may be used some Java they have used, and Python. So this in Ethereum they have used Solidity language, which is comprised of JavaScript and Node.js. Okay. So these are the tools used. So Geth is basically Go Ethereum. So Ethereum is written on Go language. Okay, Solidity language. There is tool called remix.org. If you have time, so you can go through that tool Remix, which is specifically for Solidity language. And if we want actually, so here if you wanna go, we don't want to go for complex architecture. So Solidity language is something that we can run on this tool, through which we can directly connect to our local system. Okay, that is possible. So Ganache is which provides which stores transaction details, which shows front end for transactions. So what are the transactions it happened. MetaMask is basically which connects Ganache as well as our backend structure, all the transactions. So whatever the transactions we can make, we should make through MetaMask only. Truffle is just a framework which helps to implement some of the supporting tools. So IPFS mainly we are using it for storing all the documents and reports. So conclusion, so here we are using blockchain for healthcare system. Okay, to store records. We are storing records because there are some existing models where they have used some of methods have used only to store that temperature value or heart rate. Heart rate is very small value. It can be stored inside a blockchain, but when it comes to a report, it cannot be stored inside a blockchain. There are some other tools existing like Longchain. So those are, it's not actually preferred one to store our data inside a blockchain, because if you take example of a Bitcoin, so a block size is actually 256 bytes. Okay, when it comes to Ethereum, it's 1 KB, 1 kilobyte. Okay, which is very small, which is very considerable size, where we cannot store this much amount of data. So we can store a single word, a single financial value, or some IPFS hash value I can store. Okay, so here it's the best solution. Blockchain is the best solution for healthcare system, where we can give access controls. Without patient knowledge, nothing can be shared. So patient will have full control over his data. Okay, so privacy preserving and easy and safe interoperability, because interoperability, when it comes, I'm saying suppose record is shared to someone, he cannot change it, because we have already taken that IPFS hash value and we have stored it inside a blockchain. So even though he changed it, there will be a big difference in a hash value. Okay. due to immutable property, record is stored and it is a permanent one. IPFS will helps in storing a data distributed. So IPFS itself is a distributed one. So whoever downloads that data, they can it will be stored locally. Okay, until he deletes it, that data will be stored within him. So if you have any doubts till now, you can ask me. So these are some of the references. This is my contact details. So if you have any doubts in this, you can ask me. So next we'll moving on to IPFS. Thank you. So interplanetary file system. So in this, we can observe this is actually a photo of a galaxy where data can come from anywhere. Okay, it's like YouTube, WordPress, Google, Gmail, anything news. So this data is a huge and it's very we cannot store it in at a place, and it should be distributed. IFFS is basic function I will tell. It's like a BitTorrent. Okay, so whenever we go to BitTorrent, so whoever is having that file, we can directly download that file to his system. Okay, like he should be peer, like he has to be his system has to be downloaded that BitTorrent. Similarly IFFS, but there they have not providing any security, but in IFFS there will be 100% security, like we are taking that hash value. It's a content based addressing. Content based addressing is nothing but based on that content hash will be created. Okay, so whenever there is a change in the data, that definitely a huge difference will be in the hash value. So this one we have already seen: centralized, decentralized, and distributed. So it's location based addressing. I will tell what is location based addressing, how this location will help. So whenever we type this example.com, so whenever we want to go to this page, like so actually here I need a file called baz.png, baz.png from website example.com. So internally it will call 10.20.30.40. This is IP address. So it will go to this address and it will download the file. So in blue color I am searching for the file. So you can see in the left side corner there is we don't know where exactly that file is, but we want that file. So here you can see in an orange color that file is present. So in order to download that file from 10.20.30.40, I have to find a shortest path. Okay, this is the only way I can go to that file, otherwise I cannot go to that file. So if I find direct access to, if it is nearby, I can directly download that file to me. Or so there are some problems like bandwidth and latency, what we will see. So suppose everyone is sitting in a room searching for a same page or same photo, so there will be a huge bandwidth and latency. Okay, so there will be a lot of traffic inside that, so because everyone is accessing to the same page. So this is how it works internally. It will find a shortest path. Okay, and it will be downloaded. So how IPFS will help in this picture is, So there are so many systems they are trying to access through the same path. There will be huge traffic, and due to this slowdown will happen. Okay, if we you can see this, we are here, we are using, one person is using 8 MB. Okay, so similarly it's like 240 MBs. It's huge actually. So how IPFS will help in this is, suppose this is a video we want to download. We can see, okay, there are 30 systems we are using, and this data is around 48 GB. Even 5G is can't able to handle it. Okay, so this is main drawback of it. We will how IPFS will see it. Okay, online versus offline. So whenever this only link is available is YouTube. So whenever that link is down, it's like totally that resource is unavailable. Suppose one person is downloading a Google page, so that link is down, so no one can download it, or that link is totally unavailable. And whenever data is burned or erased from our backup, so this IPFS is actually a replacement for HTTP, but it will not be happen soon, but it's a future technology. It will definitely replace it. Okay, so HTTP is just like a page not found. Okay, so it's like a link is broken, or that person is not available. So whenever I give that hash value, whenever I give that address value, so I can be able to download it. Like I can show you some of the examples. So I'll just type IPFS.io, but IPFS. I will paste this. I am able to download it. Okay, so this is a very good observation. You can observe it here. So I'm just having this hash value, nothing else. I'm able to download this image. Okay, this one I have uploaded when I was working on this. There are some, I'll just try it out whether that available or not. Okay, this one is not available. Maybe this file might have deleted, but this one is available. The image whichever is displaying on the screen. Okay, so it's actually content based addressing. Through the hash value we can download that file completely. Okay, so as we see internally, it will call IPFS, this IP address. Through that IP address, it will download the file. So this is the main agenda of IPFS. So instead of location, it will give that hash value internally. So once I download that, now in my system, this pic is available. So this pic is available. So if anyone nearby me is if he wants to or she wants to download this image, so it's directly available from my system. So it's need not to go to the same path always to download the things. So this is the difference between IPFS and HTTP. So in HTTP, only one path is available, but when it comes to IPFS, so in all the systems, that file is available. So what it will do, it will go to the nearby system. Okay, not even it will find a shortest path based on, I don't know what is the technique it use, but nearby available systems. considering the video is downloaded. Okay, so whenever that link is down, so it's that video is still available because it's already available in it's a nearby system. This is the main agenda of IPFS. So far, if you have any doubts regarding this, you can ask me. Yeah, so this is also data I have uploaded.
Mr. Raghavendra, you can continue, please. If you have more slides, you can continue. So let's
Yes, sir.
see.
Sir, actually, I wanted to show the demo, sir. I'll show you IPFS demo, how it will work internally. So this document I am having, so I will share with you guys, so you can follow these things. I have already downloaded IPFS into my system. You can see this here. So this file is there. Here application file is there. What I have to do is uh, every time I'm giving this, uh, what does it mean? This always I have to set environment variable which is not required. So instead I am using this file directly. It can go to this file and execute it. Instead of setting environment variable, I am doing this. So you have to initialize it initially so that FFS create private and public key. So this is my public key. Wherever I go, I have to use this. So now I will run IPFS. Control C. So when you get this, you are seeing successfully installed IPFS value. So I hope you are able to see this, everyone. Okay, so now my IPFS setup is ready. So my system will act as client as well as server. So now I will add one file to IPFS so that it will generate. Hash value. Please observe it very carefully. So I have copied this image. I have downloaded this. Just paste it. So here you can see this generate. Okay, this hash is generated. So here you can observe it. This is always starts with QM. Okay, QM. Now I will copy it. For that, IPFS date just Control C, Control V. Okay, enter. So now this file is pasted. Okay, so if you observe this file, it will be in a encrypted form. This file is also in a. This file is downloaded now. I'll show you where that file is downloaded. So this is the file. It has downloaded. Okay, so this will be an encrypted form. If you observe, see this. Okay, same IP. And before this, there will be on file created.ipfs. So here all the blocks are created. It's actually use Merkle drag tree. So Merkle drag is nothing but it's a cyclic graph. Okay, so in order to search that, it will be in a end login search efficiency. So that's why it is it will be in a tree structure. So these are some of the related files to IPFS. So your data will be stored here. So if you have any doubts regarding this, you can ask. And you can use one more comment. A lot of comments are available. It is actually format is not correct. It's image file, so it's showing unformatted.
Hello, Raghavendra ji. Raghavendra ji, I'm very sorry. My network is really very bad. So one more coordinator, Mrs. Professor Deepa, she'll carry out the
Okay, sir. Sir,
she'll
actually,
she'll carry out the thanks session.
okay, sir.
Okay, sir. Thank you. Sir. On behalf of JNNC Shumaga and NITK Suratkal, I thank you, Mr. Raghavendra sir, for your information session on blockchain technology applications in healthcare system. Session went well, sir. Thank you for having us as a resource person with us. Thank you, sir. Thank you very much.
Thank you, ma'am. Thank you.
So one more thing I would like to highlight. Mr. Raghavendra has got Best Research Paper Award, so from NIT Jaipur, and so we wish him all the best for his future endeavor. And so, in spite of his very bad network at his place, as well as surprisingly in my place as well, we could able to run this show. We are very sorry for the inconvenience caused for you people. But there are some technical glitches, so it is not in our hand as well. Somehow we could able to complete it. So we will assure you that in the next session such things will not happen. So we'll make sure that. So thank you very much.